Lecture 3 of 5, Topic 5, Vector, Subtopic, Application of Vector in Geometry. Learning outcome. At the end of the lesson, students should be able to A. Find the equation of straight line. B. Determine the angle between two straight lines. Equation of a straight line. Suppose that R, X, Y, Z is a point which is free to move on the line contain a fixed point A, X1, Y1, Z1. If V equal to AI plus BJ plus CK is the direction vector of the line, it is clear that a line consists precisely of those points of which the vector AR is parallel to V. That is, AR equal to dV for some scalar t. As we know, AR is equal to OR minus OA. Then from this negative OA, we move to right side become positive. So we will get OR is equal to OA plus dV. So R equal to A plus dV is the vector equation of the straight line. We know that R can write down in the vector form. So R is equal to xi plus yj plus zk. And A is equal to x1i plus y1j plus z1k. And V is equal to AI plus BJ plus CK. Now we factorize the common factor for IJK for right side. So we will get x1 plus dA for component I plus y1 plus dB for component J, then plus z1 plus dC for component K. Now we equal the coefficient of I. So the left side we get x and then right side is x1 plus dA. And equal the coefficient of component J. So we will get y is equal to y1 plus dV. And compare the coefficient of K, we will get Z is equal to Z1 plus dC. This is the parametric equation of the straight line. From the parametric equation, we get X is equal to X1 plus dA. Now we want to let T become the vector. So we will get X minus X1 is equal to dA, or T is equal to x minus x1 over A. Also, from parametric equation, y is equal to y1 plus dB. Then y minus y1 is equal to dB, or T is equal to y minus y1 over B. Also, same with the Z. So Z is equal to Z1 plus dC. Then Z minus Z1 is equal to dC, or T is equal to Z minus Z1 over C. Since for these three equations, the right side is equal, then of course the left side also equal. So we will get x minus x1 over A is equal to y minus y1 over B equal to Z minus Z1 over C. This is the Cartesian or symmetric equation of straight line. Example 1. Find the vector equation, the parametric equation, and the Cartesian equation of the straight line that pass through the point 1, minus 2, 3 and is parallel to the vector 4i plus 5j minus 6k. So first, we want to find vector equation of straight line. So we know vector equation of straight line is formula given by R is equal to A plus dV, where A is the point passing through and V is the direction. So from here, the passing through the point 1, minus 2, 3. And then the A we expect in the vector form. So A is equal to I minus 2j plus 3k. And V is direction. Direction from here is parallel to the vector. So our V is equal to 4i plus 5j minus 6k. Then the vector equation is R is equal to A plus dV. So we will get R is equal to I minus 2j plus 3k plus D times 4i plus 5j minus 6k. Next, we want to find the parametric equation of straight line. So we can expand t into direction. And then r we can expand in the vector form, where is xi plus yj plus zk. And the right side factorize the common factor of ij and k, so we will get 1 plus 4t for component I plus minus 2 plus 5t for component j plus 3 minus 6t for component k. Now we compare the coefficient of I for both sides. So for component I, we will get from both sides is x is equal to 1 plus 4t. And compare the component j, so we will get y is equal to minus 2 plus 5t. And compare the component of k, we will get z is equal to 3 minus 6t. So the parametric equation are x is equal to 1 plus 4t, y equal to minus 2 plus 5t, and z is equal to 3 minus 6t. Now we want to find the Cartesian equation of straight line. We will let t in terms of x, y, and z. So from parametric equation, x is equal to 1 plus 4t. So x minus 1 is equal to 4t, or t is equal to x minus 1 over 4. And from parametric equation, y is equal to minus 2 plus 5t. So y plus 2 is equal to 5t, or t is equal to y plus 2 over 5. And z is equal to 3 minus 6t. So z minus 3 is equal to negative 6t, or t is equal to z minus 3 over negative 6. So just right side is equal or is the t, then of course left side must be equal. So we will get the Cartesian equation is x minus 1 over 4 equal to y plus 2 over 5 equal to z minus 3 over negative 6. Example 2. Find the vector equation of the line that pass through the point A, 1, 3, 1 and B, 4, negative 1, 2. We have the point A and point B. So now we want to find vector equation of the line. So formula for vector equation of the line is r is equal to a plus tv, where a is the point passing through, v is the direction. So for this question, they pass through the point A. So our a is equal to I plus 3j plus k. And then we know we want to move from point A to B, so the direction is AB. So our V is equal to AB, AB is equal to OB minus OA. So we substitute vector OB and OA, so OB is 4i minus j plus 2k, and OA is I plus 3j plus k. So simplified, we will get is 3i minus 4j plus k. So now we have the point passing through and direction. Of course, we just substitute into the formula. So for vector equation of line is r is equal to a plus tv. So we will get r is equal to I plus 3j plus k plus t times 3i minus 4j plus k. Angle between two straight lines. The angle between two straight lines equal the angle between two direction vector of the line. Suppose the vector equation of two straight lines are r1 equal to a1 plus t b1, where the a1 is the point passing through for the first line and b1 is the direction for first line, and r2 equal to a2 plus s v2. a2 is the point passing through for the second line and v2 is the direction for second line. With the ts are any scalar and t is angle between two straight lines. The angle between two straight lines is given by theta equal to arc cos v1 dot v2 over magnitude v1 magnitude v2. Example 3. Find the angle between two straight lines r1 equal to 2i plus 2j minus 4k plus t times I plus 3j minus 3k, and r2 equal to I plus j plus k plus s times I plus 2j minus 4k. We know that angle between two straight lines formula is arc cos v1 dot v2 over magnitude v1 V1, magnitude V2. So mean that we want to find angle, first we need to find what is V1 and V2. V1 is the direction of the first line. So from here, our V1 is equal to I plus 3j minus 3k. And V2 is the direction for the second line. So our V2 is equal to I plus 2j minus 4k. So we will find the V1 dot V2 and expand, we will get is 1 plus 6 plus 12 is equal to 19. Next, we will find the magnitude of V1. Magnitude of V1 is equal to square root of 1 square plus 3 square plus negative 3 square is equal to 19. And magnitude of V2 is equal to square root of 1 square plus 2 square plus negative 4 square is equal to 21. So now we have the V1 dot V2, magnitude V1 and magnitude V2. So we can find the angle between two straight lines. So the formula theta is equal to arc cos V1 dot V2 over magnitude V1, magnitude V2. So we just substitute the result from V1 dot V2 and magnitude V1, magnitude V2. So we will get theta is equal to 18